First generation, the beginning, 1940s to 1956. The first generation of computers looked nothing like the ones we use today. They were extremely large, so big that they could take up an entire room. Inside those rooms were rows of metal cabinets, fans, and a huge number of wires. These computers didn't use modern processors like we have now. Instead, they used vacuum tubes, glass tubes that controlled electric signals to perform basic math and logic operations. But these tubes were far from efficient. One computer needed thousands of them just to function. They used a lot of electricity, produced a huge amount of heat, and often broke down. If even one vacuum tube failed, technicians had to search through all of them to find and replace it. These early machines didn't have screens, operating systems, or images. Instead, users controlled them with punch cards, thick paper cards with holes that represented data or instructions. Information was stored using magnetic drums, which were large, heavy, and could only hold a small amount of data. These computers were mainly used by scientists and government agencies for simple calculations or processing official documents. Second generation, the rise of transistors, 1956 to 1963. In the second generation, vacuum tubes were replaced by transistors. Transistors could do the same job, but they were much smaller, faster, and more reliable. Because of this change, computers became less expensive and a lot smaller in size. They also didn't get as hot, so they could be used for longer periods without overheating. Even though the internal parts improved, people still used punch cards to give the computer commands. However, data storage became better. Instead of magnetic drums, these computers used magnetic tapes, which could store more information and were easier to manage. This generation marked a big step forward in speed, size, and energy efficiency. Third generation, integrated circuits, 1964 to 1971. The third generation brought a major change with the use of integrated circuits, also called ICs. These are tiny chips that contain many small transistors built into them. Instead of wiring each transistor one by one, ICs allowed computers to be smaller, faster, and more powerful than ever before. The circuits were created using a method called photolithography, which uses light to draw patterns on the chip. This was also the time when monitors and keyboards began replacing punch cards. For the first time, users could type commands and see results on a screen. Operating systems like Unix and IBM's OS 360 were introduced, making computers easier to use. Storage also improved with the arrival of floppy disks, which were small, portable, and more convenient than magnetic tapes. Fourth generation, the microprocessor, 1971 to 2010s. The fourth generation started when microprocessors were invented. These are single chips that contain all the core functions of a computer. For the first time, the CPU, memory control, and input or output controls were all placed on one small chip. This made computers faster, cheaper, and easier to build and sell. This generation saw the rise of desktop computers, which were small enough to sit on a desk. People started using computers at home and in offices. This era also introduced graphical user interfaces, GUIs, meaning people could click on icons, use a mouse, and open files without needing to type complex commands. Floppy disks were still used, but CDs and hard drives started becoming more common. CDs were used for installing software, playing music, and watching videos. Hard drives could store much more data, such as photos, documents, and programs. The internet also became widely available during this time, changing how people used computers. Fifth generation, artificial intelligence, 2000s to present. The fifth generation doesn't focus on a specific device. It's more about the goal of making computers smarter. This is the age of artificial intelligence, AI. AI allows machines to make decisions, understand speech, recognize faces, and even learn from experience. Today, AI is used in many ways. It powers self-driving cars like Tesla, helps cameras improve images in real time using AI-powered graphics cards, and runs voice assistants like Alexa and Google Assistant. These assistants can understand your commands, answer questions, and control smart home devices. Computers today can even generate realistic videos using deep learning, making it look like someone is saying things they never actually said. This technology is called deepfake and is both powerful and controversial. Modern computers also use cloud storage, solid-state drives, and machine learning algorithms, making them faster, lighter, and much more capable than ever before. Sixth generation, the future, 2020s and beyond. We are now entering what could be called the sixth generation of computing. This generation focuses on technologies like quantum computing, neural processing, and human-machine interaction. Quantum computers, developed by companies like Google and IBM, use quantum bits, or qubits, instead of regular bits. These machines can solve problems that would take regular computers millions of years to finish. Though still experimental, quantum computing may revolutionize areas like medicine, encryption, and weather prediction. At the same time, neuromorphic chips are being designed to mimic the human brain. These chips don't just process data, they learn and adapt. These types of chips are being used in robotics, advanced AI models, and real-time pattern recognition. Other innovations include wearable computers, foldable devices, augmented reality, and brain-computer interfaces, where thoughts may one day directly control machines. We are also seeing major progress in energy-efficient computing, making devices more sustainable for the planet. The rise of edge computing, where devices process data locally instead of relying fully on the cloud, is also becoming more common, making everything faster and more secure. From room-sized machines with vacuum tubes to smartphones with AI and upcoming quantum processors, the journey of computers has been incredible. Each generation builds on the past, getting us closer to machines that not only process data, but understand, react, and even predict. This is the story of computing, generation by generation, shaping our world and the future to come.